This is where we left off. We were talking about these larger, bigger carboxylic acid groups, and we started naming these substituents. So in our first example, carbon number 5 had an ethyl group, and down here we kind of mixed in R and S notation. And then we started doing cis and trans. So we know substituents are coming. They're kind of leading us up to this. At least I am, to you. So what do I mean by that? Why is this such a big deal? Well, here's the reason. When it concerns Iupac nomenclature for carboxylics and carboxylic acids, we literally number the carbons like we always have in the longest carbon chain, and we record the numbers in the name. Okay, and that's basically what we've been doing. It's what we've always done. Find the longest carbon chain, number the carbons, substituents happen, name the substituents. On group number 4, I have a methyl group. On group number 6, I have a chloro group. On carbon number 8, I've got an ethyl group. That is basically what this rule is going to say. Nothing has changed at this point. But now, we have common nomenclature rules. We already talked about part of the common nomenclature system. Formic, acetic, propionic, butyric, valeric, caproic. We've already done that. But the issue is that never did we address how on earth we name or represent substituents off of the main chain. Okay, let me just pause. C double bond OOH. Carbon, 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 and then carbon. Oh, okay. Hopefully that's a little bit clearer. Iupac Name. Iupac Name says, Tracy, go in here and find the longest carbon chain that contains your carboxylic acid. Okay, 1, 2, 3, 4, and 5. There's 5 carbons in a row. So 5 carbons in a row is going to be called pentane. Drop the E. Oic acid. Pentanoic acid. All right. And then it looks like at carbon number 4, I have this little bitty methyl group that's hanging up at the top. All right. So 4-methyl pentanoic acid. Folks, I got it. There's the Iupac name. 4-methyl pentanoic acid. Now, common name it. Okay. So common nomenclature told me that I need to find the longest carbon chain just like Iupac. Yeah, that's right. So there's still 5. But I don't use the word pentane. That's Iupac stuff. I need to use something else. Okay, the 5-carbon word that we use in common nomenclature is valeric acid. Okay, but it's not just valeric acid. It's not just valeric acid here. Because we've got this methyl group that's still hanging off. So if you look at this and you go, oh, well, this is fine. This is 4-methyl valeric acid. Wrong. That's not what we do with common name. I know it can't be easy, but that's just the way it is. The reason is because there's a number here. That number is really reserved for Iupac system, not common system. Okay, so now how do we do this? This requires yet another specific system in place that is for common nomenclature. And this is what happens. Here's the carbonyl carbon right there. There's my first. Next to this is carbon number 2. In the common nomenclature system, this is also regarded as an alpha carbon. Therefore, Greek letters, Greek alphabet, yep, foreign language. Beta. The next one is gamma. The next one would be delta. The next one would be epsilon, and so forth. We really don't find anything greater than 5, quite honestly, in any of these examples or on these entrance tests that you see. So we don't really have to worry about anything after alpha, beta, gamma, delta, epsilon. So what this means is that I'm close. In the common nomenclature system, I am close if I put 4-methylvaleric acid. However, common says, no to 4. You can't do that. You can't put 4 there. What you have to put there is the Greek letter that's appropriate for it. So there's alpha, there is beta, there is gamma. So that means that this is gamma-methyl valeric acid, Power Ranger, go! And that's what that basically is. Alpha, beta, gamma, delta, epsilon. So the Iupac system, very easy, I think, based on what we've always done in Chem 251 and Chem 252. You find the longest carbon chain, you name the chain like normal, you add oic acid at the end, you use the numbers to associate the substituents with. Carbon 1, 2, 3, 4, 5. However, in the common nomenclature system, pretty much everything changes. We don't use the regular pentane, butane, hexane, and so forth. They have their own common name that we have to memorize. And then we name the substituents just like normal. I mean, if methyl's there, we still name it methyl. But we don't use the carbon numbers, 1, 2, 3, 4, 5. We use alpha, beta, gamma, delta, epsilon instead. And to throw little kinks into the system even more, look, I did not give the first carbon the alpha position. That is not what we do. The alpha position is not given to the carbon of the carbonyl. We do not count that one in the Greek alphabet when it concerns the common name. We count it in the longest carbon chain, but we do not count it in the alphabet when we go and assign things as alpha, beta, gammas. All right, so 4-methyl pentanoic acid or gamma-methyl valeric acid. So, let's use this now, and let's focus on some examples. And here's our example set. Draw the following. 2-methoxybutanoic acid. Okay, now wait a minute. We haven't talked about methoxys, have we? Yeah, we did. That was Chemistry 251. That is when methoxy should have been introduced to you. You should have seen methoxy, 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 methoxy over and over and over and over and over. That word at least should trigger something. And maybe with a quick review, maybe you'll understand. Oh yeah, I remember that. I hope. So let's draw this thing. I'm going to start down here at the very bottom. Butanoic acid. All right, so 1, 2, 3, 4. There's but. Look, it tells me Iupac. I knew it was Iupac because I see a number. It didn't even have to tell me that. Okay, so at carbon number 2, whoa, wait a minute. Butanoic acid. I'm not really finished. That means a C double bond OOH at the end. There's my carboxylic acid group. So on carbon number 2, 1, 2, here we go, right there. I could draw it up, I could draw it down, I don't care. Just draw it somewhere. On the second carbon, I'll have a methoxy. Meth is what? It's a 1-carbon chain. Oxy represents oxygen. Okay, well, I need carbon to have enough bonds, so this is an OCH3. There is methoxy group. There's a quick review of that group that should have been presented in 251. 2-methoxy butanoic acid. Right, there you go, folks. There's the structure. Take it to the bank. Now, ethoxy would be 2 carbons with the O connected at that spot. Propoxy, 3 carbons with the O connected at the spot. All right. Next one. Next up, we'll get rid of all of this down here. I'll just keep it to the same screen. 3-chloropentanoic acid. All right, pent is 5. 1, 2, 3, 4, 5. Oik! Double bond OOH. On carbon number 3, 1, 2, 3, right here, I have a chloro. Hopefully, to goodness, you know what a chloro group is, Cl. And there's your structure for 3-chloropentanoic acid. It tells me Iupac. I knew it was Iupac. It gives me a number in the beginning. All right, so that one, hopefully, not too bad, right? Not too bad. You got this. You're learning. All right, next one, 2-ethyl heptanoic acid. All right, so hept. 1, 2, 3, 4, 5, 6, and 7. Oic acid. Oik. Double bond OOH. 2-ethyl. Carbon 1, carbon 2 right here. And that is a ethyl group, which is a CH2, CH3. Now, folks, keep in mind, I'm shorthanding them this. I'm assuming that you know that hydrogens are all the way down through here. Meaning this carbon has 4 bonds, it doesn't need any more hydrogen. This carbon has 3, so that needs a hydrogen to give you 4, and that's a CH2, and that's a CH2, and that's a CH2, and this is a CH2, and this is a CH3. I'm assuming that you know those hydrogens are there, so don't leave them off. They are there for me. If you leave them off, I assume just like you assume, so therefore I give you credit. But in a formal problem, you would want to include those hydrogens because they are there. Or draw the skeletal structure. It's up to you. I don't care. How do you draw the skeletal structure of this? Okay, well, let's review that really quick. 1, 2, 3, 4, 5, 6, 7. All right, so 1, 2, 3, 4, 5, 6, and 7. There's my 7 carbons. 1, 2, 3, 4, 5, 6, 7. On the 7th carbon, I have a double bond O. So double bond O and then an OH. I could point it up. It looks a little weird if you point it up because it runs into that little line. So that's why I draw it down just to get it away from it. And then on carbon number 2, which is right here, I have a 1 carbon and a 2 carbon. There's the ethyl group up at the top. If it suits your boat, do it. If it floats your boat, do it. All right, so let's get rid of this one. And we move on to our next example. The next example says beta. Beta. Bromo butyric acid. It's like the beta wolf. You ever watch Teen Wolf? MTV? There you go. Beta and alphas. All right, so beta bromo butyric acid. Butyric. Bute. That's 4 carbons. 1, 2, 3, and 4. Double bond OOH. There you go. There's butyric acid. But this time it's beta bromo. Now keep in mind that carbon in Greek alphabet does not get counted. So this is alpha, this is beta. So at the beta carbon, I have a bromo group, and surely you know that that's a Br. So there is beta bromo butyric acid. All right, now we do our last one on the screen. And that last one is gamma. Gamma. Chlorovaleric acid. Valeric. Now they're trying to test me. Valeric is 5 carbons. 1, 2, 3, 4, and 5. Valeric acid, ic acid, is COOH. Gamma. All right, so alpha, beta, gamma. There it is. So at the gamma spot, I have a chloro group, which is a Cl. Folks, there's your structure for gamma chlorovaleric acid. All right, so I think that's enough to get you through the nomenclature of carbonyls. So Iupac and common. We'll find the longest carbon chain in both. We name substituents in both. The difference, Iupac, we number just like we always have. We use the numbers in the name. In the common nomenclature system, we use the Greek letter alphabet, alpha, beta, gamma, delta, epsilon. We still find the longest carbon chain. We still name the substituents just like we have before. But the key problem that people have is that they want to put the alpha here because that's the first carbon. And that is not what you do. Do not start alpha there. I say it because it happens every single time in every single class in every single semester. You gotta not put a Greek letter at the carbonyl. You do count it in the longest carbon chain. Remember, I said kind of back in when we started nomenclature for the carboxylic acids? Oh, you'll understand why people kind of question, do I count this first carbon or not? Yes, you count everything in Iupac. Every carbon gets counted in Iupac. In the common name, it does not. In the common name, when you get to the Greek letters only, that does not get an alpha carbon. Alpha starts beside of it. All right. So, with that said, I probably confused you even more, and you probably hope that I would have never said what I've said in the past few minutes, because now you've just confused the heck out of you, maybe. Who knows? Who knows? I just try to warn you, though. That's all I did. I try to be good. All right, so in the next video, we'll move on to our next functional group, and our next functional group is going to be acyl halides. That's what we're going to learn how to name next. So, in the next video, that's where we'll pick up.